Okay, so it's better. Okay, so it's flexibility, agile, good. So we are making it Scrum, and we will continue with the second session. And I'm pleased to to invite Dr. Guy Haller to animate this session. Thank you, Guy.
Thank you, Yassine. So it's a pleasure and also a new experience for me because I work at Geneva University Hospital. And we had a wonderful project with Yassine regarding mixed reality to improve human factors and behavior in delivery rooms at our hospital. And it's a great honor to be invited here to chair the last session. So the last session will be about 3 topics. The first one will be about chemistry, and you know that chemistry is quite a tricky topic, and to understand how energies fit together and how molecular building larger molecules can be done and how it has to be done is quite complex. So it will be a great pleasure for me to invite our first speaker. This is Mrs. Olga Reinauer, sorry if I mixed, and she invented a really great game, so I had the pleasure to read it all through. So it's a big battle happening between molecules and towers, and so it seems really great, so we look forward to listening to you. Thank you. Thank you.
Good afternoon. I would first like to thank you for giving me the opportunity to present my project. My name is Olga Reinauer. My educational background is chemistry and material science. And in my free time, as a personal hobby project, I am developing a game for undergraduate chemistry students. And today I will present my motivation, what issues I'm trying to solve, and most important, the game development process. When I was studying, I always wondered why so many people around me dislike chemistry and find it too complex. And while looking at the literature, I found out that there is, in fact, a complexity specific to chemistry. It is very difficult to link the properties of compounds around us and the structure. To give you an example, to explain the properties of ice, one has to start with the atomic properties of hydrogen and oxygen, what type of bond they form within a molecule, and then how water molecules interact between each other to finally come to the properties of the compound. For instance, Professor Johnston proved that making this structure property link demands an unreasonable cognitive effort from students. However, this is the core of chemistry, and this link has to be understood. That's why I wanted to develop a game that helps students make this link, because the majority of existing chemistry games, they're targeting a specific issue. For example, balancing equations or calculating solubilities. But I wanted to make a game which connects structure and properties. In order to help students build this link, researchers in chemistry education suggest structuring the course around certain topics and connect them in a certain way. For example, in the curriculum developed by Cooper and Klimkowski, researchers suggest connecting atomic properties to the energies of forming and breaking bonds inside the molecules, and then the forces of interactions between the molecules, which are finally linked to properties of compounds such as melting points, solubilities, conductivities, and so on. So I wanted to create a similar connection. And here on this slide, I'm presenting the learning material which is integrated in the game. I want to show how atomic properties affect the type of bond they formed, and then I wanted to connect this to interactions between molecules and finally link it to the properties. And to do that, I used a number of different game mechanics. I will explain it later to you in more detail, but just to give you an overview, I have atoms represented as a collection of characters. And the player has to merge them to craft compounds which finally will be played as towers against enemies. I will now explain it all in detail. I will start with the collection game mechanic. I was observing my kids playing Pokemon cards, and I've noticed that after some time playing, they could remember by heart all of the properties, the evolutions, the points, the life points, and so on. So I wanted to reproduce the same effect. So atoms in my game are presented as characters. What is important is that they have a distinct visual style depending on the type. We have metals, halogens, and so on. And they represent orbitals in a symbolic way. And what is good that they have distinct properties which could be guessed from their position on the periodic table, which is always visible to the player. Then I thought how one would connect these atoms together to form compounds. This is the most complex part of the game, which took me the longest to design. So I used here merge mechanics. Merge game mechanics basically consists in building more complex objects from the building blocks in a limited space. I have here, you can see I have a crafting arena where atoms are appearing, which has a limited size, and the player has to merge the atoms together. When he does that, he has a second screen which appears, and on this screen we see a formula of the compound these atoms form. And then the player has to select the correct type of intramolecular bonds and intermolecular bonds. And the player here has all the information necessary. For example, from the position of the atoms on the periodic table, he could estimate the electronegativities, and then he could estimate which bond type these atoms form. And already there, the player starts having an idea about the properties of the compound. For example, metallic compounds would rather have good conductivities, ionic compounds would rather have high melting points, and so on. And then player selects the connections between the molecules, and we have, they are ranked from increasing to decreasing strength. And while repeatedly performing this action, the player already starts having an idea about the properties of the finally formed compound. Compounds here are also have distinct symbols. For example, metals have a metal sphere, liquids have a shape of a flask, and salts have a shape of the gem. And these compounds are used as towers in a game, which means that they will be fighting against enemies. And here I have the type of enemies, the solvents. So to withstand the attack of solvents, one has to select the compounds which are insoluble. We have heat waves, so one has to select compounds with high melting points. And we also have a notion of conductors, semiconductors, and insulators to fight against electric current. Now, to bring it all together, I'll give you an example of a typical gameplay. We have an enemy which starts moving on the battlefield. It is a heat wave with a temperature of 600 degrees. So the player has to evaluate if compounds present on the map have the melting points above or below this value. If no such compounds are present, the player has to build them from atoms. And my idea is that by repeatedly selecting compounds with the correct properties, by repeatedly selecting bonds, the player integrates the learning material. So Currently, the game is in the final stages of development. It can already be played with 200 compounds built from approximately 20 atoms. They are only simple compounds, pure or binary, which cover most of the necessary theory. What I expect is that students would be better able to predict or compare the properties of compounds based on the formula. And this could be tested with standard assessment, written or oral. Of course, this game cannot replace a traditional course. It is intended to be used as a complement because it has no quantitative methods. There are no calculations, no balancing equations, but it is intended to show in what context these quantitative methods are used. And my current needs are mainly the feedback and advice. I'm looking for advice from professionals in serious games and from professional educators, because up until now I did all by myself. So if you have any advice or tips how I could improve this game, I'm looking forward to it. And eventually I would like to test this game as well with students. And I have a demo on my phone if you are interested to see it. So if you have any questions.
Thank you. Thank you, that's really great work, and I haven't thought that we could make chemistry as a game. It's been always a nightmare for me. So, Yassine, you probably have a question.
In fact, if it's not a question, but it's a comment. You said you need help. I think we are learning about you because it's fantastic. Really, the idea is innovative. How to make chemistry as live and attractive. It's a nice paper. I enjoy reading the paper and learning it. So it was just a comment. I'm a fan.
Thank you very much.
Thank you, Yassine.
Yeah, I like the project. I'd like to play it. I was wondering, so if I understand correctly, you're sort of an autodidact in terms of game design. Is that right? You're just learning on the fly game design?
I did everything myself. Yeah.
Okay. Did you look at certain types of popular puzzle type games, and were you inspired by, I don't know, Threes, Candy Crush, all these sort of,
Yes.
What games were you looking at?
Yeah, yes, definitely. I was inspired by several games, particularly Plants vs. Zombies. It's a casual game, it's a casual tower defense game where all the characters attack specific types of enemies. And also I selected this casual design because I looked at the people who play such casual games, and I have seen that the target audience are young people in their 20s, which is also the target audience for introductory chemistry course.
Okay, great. I was wondering, how did you set the boundaries? Because you can build up all the world just by putting all molecules together. So how did you decide, okay, I stopped there, and you mentioned that it was 20 main molecules. What made you decide that?
Sorry, there are 20 atoms,
20
and
atoms.
there are 200 compounds.
Okay.
What made me decide is first the time I had available, because of course we can build everything, but it was physically not possible. So I selected the atoms which I guess, because of course some atoms have redundant similar properties, so I selected some very characteristic per group, and I made components between them. So I made a table of X, Y, how everything interacts in a possible way. I selected only simple molecules with one type of bond present. The only molecules we have only one or two type of atoms. So it was selected mainly to simplify as much as possible while still keeping the whole theory necessary for the students.
So you use the game as a way for the student or the practitioner to understand basic mechanisms,
Yes.
rather than building up molecules forever.
Yes. The mechanism was really to link everything in the connection.
Any other question in the audience? No? Then I may have a last question. How do you plan to test it? Would you have some sort of trial, or users that take your game, others who do not, or just how do you see that?
Yes, it would be something like that because, for example, there are standard tests which can be used to rank molecules according to their melting points and so on. And there will be a difference, two groups, one playing the game, another one not playing the game. And I assume that would happen throughout one semester. And at the end of the semester, both groups will be evaluated depending on how they were playing the game. It is intended to be used as a short playing sessions of 10 minutes or something like this, which can be played anywhere, not necessary during the course. So
Excellent.
that is the idea.
So we hope for positive results. So thank you again. It's a really beautiful project.
Thank you.
So I'm pleased to invite our So we are pleased to offer you this. Thank you. The contribution. So I'm pleased to invite our second speaker. This will be Mrs. Noria Foukia. So it's a joint project between the HEPIA in Geneva and the HEARC in Neuchâtel. The project is about environment and waste management, and it's really a beautiful project about how to use artificial intelligence to triage waste. So we really look forward to listen to your presentation. Thank you.
Thanks for the invitation. Actually, I'm not going to present the project because the assistants work on it hourly, so they are to do their job.
Beautiful. They have to do it. So they will.
So I start. Good afternoon, everybody. I'm Swan from HEPIA, and today I will present Lustra project. Lustra means ludic trash. I will present the context and the objectives, the gamification part, the machine learning part, then the result, and I will conclude. In Switzerland, the recycling rate has reached a plateau, and the incorrect sorting waste is a real scourge. Sorting waste doesn't seem to be instinctive, and sorting errors cost to municipalities. Our proposal is to build an educational tool as a sorting game mainly for primary school, as well as developing a logistic tool for the manager. Our objectives are is to motivate. Our objectives are to create a motivating and playful sorting system for young public, to make them responsible for their sorting behavior and right gesture. Our system is an interactive, incentive, and rewarding gamification system. We want a trash that automatically recognizes the type of waste that is thrown into the bin with a machine learning model trained on real sensor data. We are currently working on pet recognition, metal recognition, and glass recognition. Here is your gamification prototype that you can see at the demo stand. Here is the trash prototype. As an embedded system composed of a Raspberry Pi that executes the waste classification application from images captured by a Pi camera. Since the trash is dark, the light source is added. We also used TensorFlow and Keras library for the machine learning part, and we trained our model with NVIDIA GPU. The trash bin and the game platform are connected. When the child throws a waste into the bin, this launches the game as a fortune wheel. The game rewards the shield in case of correct sorting. Then the shield continues to play with the virtual sorting game to learn how to correctly put the waste at the good location. The pedagogy aspect mainly focus first to the playful aspect to motivate the child to take part of the waste sorting. Second, the educational aspect to teach the child for his sorting behavior and have a reflex to eco-gesture. Third, provide the feedback to the child, the teacher, and the manager without discriminating the child against his sorting behavior. Here is the embedded application execution flow. First, we load the TensorFlow library. Then we start recording the video. Then we search to detect a moving object. If there are a moving object, we take a picture of the object. We classify the image with the machine learning model. Then we send the image to the server, and we come back to the detecting moving object, etc. Here is an example of the output of the classification. Here we have the machine learning algorithm used, the classification, and the probabilities. We recorded 200 of pet images and 200 of other waste images. Here is an image sample. The classification result of 7 machine learning models show that we have more than 90% of success rate for pet vs others category. The errors mainly come from bad discrimination between class and pet bottles. As you can see, in these error images, we have a majority of bottles. And I will introduce. This is David Gonzalez. it will present the game interface.
Here you have a video of the first voilà. The first prototype of the game, the graphical game for the child. Here we can see. Here we can see the home screen of the interface. You see after trash, it is rainy, it is windy, it is not very nice come like the waiter. So when the child put a trash in the trash bin, it will send a signal to the application, to the game. Voilà. It will send a signal to the game, and then he will have a feedback of his put-in, and we notify if he has done correctly. Here we have all the trophy has won as far, and then you can play a virtual game where even if he has wrong, he can do retry until he does good correctly. Here we have the wheel to gain the trophy. And then at the end, you see the waiter has improved so that the child have a visual feedback of his sorting. It has impact on the world he lives in. Then at the end, we have this nice animation, the blooms, nice flower, to show the child how the world is beautiful without pollution. Je te laisse continuer. My colleague will then conclude.
Lustra can be extended to 4 types of waste, with mainly focus on pet category. We can improve the camera with infrared light and add other identification techniques. We will build a fully integrated device, and also we need to work with pedagogy expert and design specialists. Thank you.
Congratulations, it's really a fascinating project, and we can see in our Geneva bins tomorrow your system just telling people who put whatever in the bin just to tell them what they could maybe put it elsewhere or somewhere else. So there's plenty of opportunities for the future use of this idea. It's really brilliant. So I don't know if there are any questions.
Hello, and thank you for the presentation. I just had a question on the feedbacks, the positive feedbacks, trophies, etc. And in general, for serious games, I'm not sure we think enough about the positive feedbacks we're giving. In this case, it's a nicer weather, which is a sunny weather, maybe providing some desertification and nice cars, etc. While it's actually a game about sustainability. So I'm just curious about whether you've thought of the positive feedbacks you're providing, are they linked to the theme or just shiny big cars?
It is for the moment really, it is random, I say it, because we have not, we have not already asked experts on this matter. It is a next step for the project. So it will come, but at the first prototype we have here, it is for now like this.
Thank you.
Thank you.
Any other question?
Yeah, I have a question. I didn't understand exactly what is the deployment scenario. Is it dedicated to be used in a best scenario? I don't know. I'm not speaking for tomorrow, but the best scenario will be to deploy that in the city and having a feedback through an application, or is it intended to be used in schools or something like that? What is the usage scenario?
We will deploy it in schools and also in festivals and events. It's the main goal is to
the main goal of the project is to educate. So we put it in special events in partnership with schools, partnership with schools and other association company.
Thank you. Nice.
Okay, last technical question. Usually when you use artificial intelligence, particularly if you use images, you need many images to improve the precision of the tool. And here with 200, you had a precision, what you call effectiveness of 19.1%. So it's quite impressive. How did you manage to get that number with 200 bottles?
Il demande en fait combien le pourcentage.
Oui.
Il est très élevé et du coup il demande comment tu as fait pour ça.
I use the convolutional neuronal networks models for training, and I tested 7 types of models already developed by Google, Microsoft, or other, and I used machine learning techniques to improve to a maximum the performance. The machine learning techniques are normalization of data, data augmentation, transfer learning, and a step of post-processing to change the decision threshold of the neurons.
Swan, excuse me. Perhaps precision. The question is more about how did you get high precision with few training data? Is it normal or not? I think this was the question.
This was the question,
yeah.
Yes.
Is it normal to get 90% of precision with only 200 objects?
After augmentation of the data, I have more than 1,000 of images in the data set.
Explique les modifications que tu as faites.
The data augmentation step is to take one image and apply rotation, zoom, translation to duplicate one image to many images.
Okay, that makes sense then. Thank you.
Okay.
I think Swan, at the beginning maybe he didn't understand the question, but what he did, this is actually what he just answered. He got these 200 images step by step. It was in the scope of his master's thesis, and also for David, it was master's work as assistant in our labs. Actually, he spent many times, this is what you said, I spent many times to get these 200 images from real cases that he put in the trash. Then he used well-known artificial intelligence techniques to augment and to get more images from the beginning, because we know that the learning stage is really important. And the next step is to make the manager to discriminate between the false positive and the false negative, to resend another training stage so that we get more precision, better quality in the system. This is what we try to do now. Thank you.
Yes,
Very tidy.
The images don't come from internet.
Yeah.
Okay, so
The data is self-made. You made your own data. Okay,
Yes.
nice.
excellent, and we look forward to see the project tomorrow in Geneva. Congratulations. Okay, thank you.
Thank you.
I won't forget the attestation. I think it's for you, son. Pleasure. So our last speaker, who is, I think, known to everybody, it's Professor Yassine Rekik, who will present us the last project of the day. So it's a collaborative work between the l'Office d'intégration et de formation professionnelle, so you probably know about this office. It's here in Geneva to help trainees who are sometimes in difficulties to improve to acquire a job, to train them, and with the HEPIA. And it's all about a project how we can use mixed reality to improve training without having adverse consequences of glasses on whatever falling on the floor and breaking down. So I could try it before. It's quite impressive. So I look forward to it.
Thank you, Guy. Hi, everybody. I have to confess something before starting my talk. It's a very nice simulation, and I said that for our president because he will not be happy about my talk, because there is not enough gamification, and I confess it, I admit it, but I like so much this event, so I find any occasion to write a paper and to participate. So I know that my game is not, my simulation is not as gamified as that. We are at the first stage, but yeah, I will try to present it, but it's still a very nice application. Okay, so let me present the context. The context is that it's a collaboration between HEPIA and ORIF Professional Training Center, and the idea is that for professional training, you know that the best way to train something is to put it in the situation, situated learning, to simulate real life situation. But real life situation poses many problems, logistical problems. You have to put setting, etc. It's very costly sometimes, and there is also sometimes problem of security. Sometimes you cannot access some sites or some configuration or context. So simulation mode is the best way to solve all these problems, and this is the objective of the project. So the objective of the project is to build a solution allowing this training center to offer multiple simulations to their apprentices. The problem is that we wanted to have something which is generic, not building one application for each, for example, context or for each business. So, for example, we discussed with this center and they said we have cooking curriculum, comment on dit les pâtissiers en anglais? Sweets maker curriculum, security agent curriculum. We have maintenance, mechanical maintenance curriculum. And we don't want to build any year a different tool. So is it possible to make it generic? So we worked with them and we tried to make something generic. And what is generic in all this business is that there is a process, and in general this process is linear. If it's not linear, is with some bifurcation, some choices at the middle, but it's not so complicated. And within this, let's say, sequence of tasks, any task requires some achievement and requires some tools and some theoretical support. So we take this model and we try to implement it with three important goals. The first one is to be generic, as I said. The second one is to be as realistic and immersive as possible. And the third one is to gamify this process. So this is the model. The model is always a generic path, and then each task we associate to this task an appropriate scene and 3D objects to manipulate, some achievements and constraints. We have hints and theoretical supports, and we gamify all these for each task. So this is the generic model of the application. In terms of technologies, the project is based on augmented reality, so we are using HoloLens 2, and we are developing all the application using Unity, so nothing special about that. And to validate our approach, we have selected one context in order to make a proof of concept, and it was not our choice, it was the choice of the center. They said, this is something we dream about it since many years, how to teach people from service jobs how to dress tables, because there is a strict codification for that, and it must be parallel 2 centimeters between them, right, left, there is an order, etc. So it's perfect to test our model of task-based process. So we worked with them in order to build a model for this job, for this business, which is table dressing. And on top of that, we have, as I said, tried to insert, to put some gamification. Again, I'm saying it's not so developed. We only used 3 kinds of gamification aspects. First, we have the scoring aspect. The second gamification aspect is that we have created within our tools something called like missions. And the idea behind missions is that we can work in group competitively or cooperatively. And this can give some motivation. And also we have a mode within our tool, which is what we call time constrained mode, because in the training mode, there is no time constraints. He can make and get hint and correct himself, but there is an examination mode where the time is stressing, and if he spend more time than expected between 2 steps, it's degrading his score, etc. So there is some competitive and time constraining aspects. So now the current state is that we have developed the generic model allowing defining the general process. We have modeling the tasks about table dressing. We have developed I'm sorry, sometimes we can take, if it exists, sometimes we can take some objects if they exist. So we have developed scenes and 3D objects required for table dressing. And we have developed now only the training mode. It means no time constraint for now. And the result is that I will show you a small video to show you the state of progress. So again, it is on progress. We worked on that only for 3-4 months, that's all. So this is the scanning of the room, and this is the room of my assistant. I'm sorry, we didn't test it in a restaurant yet. Here is to set up the table. But here also we have the choice between using real table or using virtual table. This is what they call feuille de fonction. It's the mission you have to accomplish. Number of people, what kind of plats or dishes, etc. And here he has to follow a precise protocol to get the right, the appropriate, how we call them? Les couverts. Okay. Yeah. So here's the selection mode, and here he has to set up the table, to dress the table. And as I said, there is a lot of rules. I discovered a lot of things doing this project. So we have a lot of constraints of sequencing, which must be put before the other. There is relative positioning, absolute positioning, distances, orientations. So there is a lot of things. It's very funny. And of course, the application is, because here we are in the training mode, so there is a lot of hints. For example, he has some representation of the position, etc. In the examination mode, he will have no hints, no help. It will be blended mode. Yeah, so you get the idea, I think. So I will skip and continue. Good. So as I said, this project is still in progress. And what we are targeting in the few next months, because we have get a fund from a foundation to continue this project and to package it and to use it in the ORIF Center, and we are also negotiating that with the École Hôtelière in Lausanne. And the idea is to have the full version of table dressing first, and then to extend that for the whole what they call service jobs. It means not only dressing the table, but also taking commands, serving, cleaning, etc. So the whole process. And then also the idea is to use this same tool for other business, as I said, like cooking, site security, mechanical maintenance, etc. And this first prototype, which is dealing with table dressing, will be used and tested in the next semester within ORIF to get some feedback. So until now, we have tested locally with professor and us as developers, but it's not very. It's just to have a feeling, to have a first impression, which is encouraging. But we need to make real tests, and we hope we will manage to do them in the next semester at September. Thank you very much.
Thank you, Yassine. I'm sure there are some questions.
Thank you. Can we test it upstairs, or? Yeah.
Yeah, it's upstairs. Yeah.
All right. So I wonder, now that you've tried one test case, what's your feeling of how much reuse you'll be able to do for another different task, and how much customization you'll need to do for?
Yeah, we have thought about that since the beginning, and as I said, we have tried to split the problem into two parts. The generic skeleton, let's say, can be with high level of reusability, because many processes are based on sequence of steps. So for this part, the generic way of running, with, of course, with the function to test the end of one, the dependency between tests, etc. This is very generic. Which is very specific is the tasks themselves. What you need as a scene, as objects, and as manipulation. And for that, to be honest, it's more or less 100% you have to redo it for any context.
Okay, another question?
Okay, indeed a very nice idea, and in general also the application, I tried it before. And about the evaluation, when we will use in the building where ORIF, thanks. And the evaluation will be based on timing, but also on the accuracy of the positioning of the spoon, fork, and so on.
There is 3 criteria mainly.
Thanks.
Thanks for the question, Fabio. there is mainly 3 criteria. The first one, as I said, is the sequencing of steps, because it seems that for them it's very important to start with forks and then plates and then decoration and then bread, and it cannot be the opposite. I don't know why, but this is their job. So it's very, very precise and very strict. So it's the sequencing. The second thing is, as you said, positioning. So it's a question of orientation, proximity, absolute positioning, right or left, or is it horizontal or vertical? And the third one, of course, third aspect is time, but time is very important also dealing with the how to say it? It must be appropriate for the event, because it depends on the number of people and the kind of menu they have selected. The dressing change. So the students have to discover his mission and to make the right choice in rapidly and to execute it rapidly. So this is mainly the challenge.
Okay, another question? I have one. I was wondering, what's the advantage of making it virtual, because you can do analogic simulation as well. So we could imagine having a table dressed with plastic plates and so on. So what kind of advantage do you see by making it virtual or mixed reality?
In fact, when we discussed with them, they said that it is not as easy as that to get access to restaurants, to real places, and to learn. Even in the school, in their training center, they have some places, etc., but they are not accessible all time, because you need a key, you need to have a professor with you, etc. And the idea is to let them learn that by themselves, self-training. So the idea is to develop self-training, and if we need self-training, the idea is that the students launch the application in the library or at home. If he has HoloLens, it costs only 5,000 francs. So he has but yeah, now it's 4,000, but perhaps with the glasses, etc., it will be 500 in few years. But the idea is to encourage self-training, non-supervised training, and to give them access. And I'm sorry, also, it is not always easy to have all the, encore une fois, les couverts, all the cutlery. It is not easy to have all of them and all the kind, etc. So it is easier to have a 3D model, and it's okay.
Okay, so you would see that as a complementary tool to
Yeah,
traditional teaching, and
of course,
not to replace it.
Yeah, of course. It will never replace real and on-site learning and training, but they said that they have noticed a lot of exam failure due to this step in their school. So this is why they said we need that at first example.
So I think
it was their choice, as I said.
So I think many students will love you at the end.
I have to be paid at the end.
Excellent. So any last question? Or?
Thank you, Yassine, for your presentation. Actually, I was wondering, we work in the same school.
It seems, yeah.
It seems. We sometimes manage to be together in the same room.
Yeah.
And we never speak together about what we are doing. I mean, I was just wondering, this is a pedagogical aspect that you are speaking about. So what we do is also try to train young people, young public to have a co-citizen, what we call gesture.
Yeah.
So how could you make that you work with me and I work with you?
You pay the coffee. So first you have to pay the coffee. And we have to raise communication and to collaborate more, because it's general. You go to all the institution and all the school, you will find people knowing extra people more than their neighbors, but we have to work on that. I will be very happy to work with you, Nuria. Thanks. Thanks.
So I think it's a beautiful conclusion, just working together. So I think we can applaud our last speaker also.
Thank you.